Hello everyone. Okay, I was trying to, as the streaming title suggests, I'm solving I'm solving a simple cache system, and I'm solving a simple cache system. I'm going to first share the live stream. Maybe somebody comes. I'm only gonna live stream till 11 p.m. here, so like in half an hour. But I I need to. I was so tired that I couldn't get to study. I studied a little bit of English and did Platzi the Platzi what? The Platzi challenge. But my plan has gone from focusing more in solving problems and then studying English using the English that I have. But I was really tired. I don't know why. And I thought, well, I just rest the whole day, but no, it's better to study a little bit. Okay, apparently somebody's watching. Hello. Okay, so I'm trying to solve a cache system, and I was thinking of using two two dictionaries, but the problem with in an order of arriving, and I put the time, but then I tried to get this time. So I had a problem. I had the web page and I was getting the time. Um, I was getting the time. The thing is, when I get to remove a web page, I need to not only access the my cache faster for the web page. That's done every time you get a web page, or every time you put a web page, whatever. Uh, uh, let's say web page. Let's stay with that. And that need to be done fast. Getting the web page, or putting the web page. That needs to be done fast. But you also need to remove somebody fast. When I try to solve that with the time, having a unique time, having a just a time that goes up, I try to solve it with a heap, and it's cool. I keep the times, these times, this times sorted, but I can't, I cannot find, I cannot find. I only sort by time. If in the heap that has the times, accessing the web page is linear. Okay, I need to I need to connect my cell phone. I'm gonna be right back. Hello. Okay, so I have sorted by this time in the heap, but getting to this web page is static, is linear, is O of n. I have to go from each one of these nodes. So I was looking how to solve that. How to solve that. So simple cache implementation, caching in Python. And what I found, simple cache experience. Okay, something with an explanation. What I found was that they use something that has already been done, an LRU map, a least recently used map. It's the same thing that I explained in the first part. The older web pages get removed. If you access it or you put it, you change the time. But if you have a web page that is too old, you just remove it. And it's already implemented. So maybe from there is not the way. How did I find the solution? A solution. I just went to YouTube and search cache, simple cache, and this appears. All earlier you cache. After I had understand what is an LRU cache.
What is a model? I think you can ask a million people.
Okay, so
Get started with terminology.
I'm going to put this video.
LRU and what is a?
I'm going to put this video in the description. He explains what's an LRU cache, and basically what I just told you, that the older cache just gets deleted, and how he solved that. He solved that with a hash table with a linked list. The thing is, he has a double linked list. Anytime you access something, you put that thing in the first part of the linked list. Like that. So, and each one of these values are also in a hash table. So you don't have to go for each node to find one of these items. Wherever you go, you add things. You add the 10, and you need to remove one. So let's see, he gets another one. So one goes to the first spot, and everything gets moved. See? See how everything got moved? And now he gets another element. He gets another 4. Well, everything got moved again. And he gets a 5. And the last one got deleted. The 3 got deleted. Okay, so let's try to solve that. Simple cache system. The first thing we need is a double linked list. Python. In Python, in the standard library, there is not double linked list. There just arise. A double linked list. Can we solve that with an array? No, because when you delete something, that is going to move the whole array, and that is going to cost. Okay, I'm seeing. See the live stream. Okay, the one that was seeing abandon us. That was that. Okay. Okay, so I need a double linked list. I can implement that, but that's something I'm going to use a lot. So when I'm going to use something a lot, I try to find something that has been already done. And has been already tested. So I get the approximation of the other programmer, and I also take advantage of the testing. So let's say double link this, double link this in Python. Tutorials on point. Okay, Geekstone. Version, double link this, double link this. This sounds weird. Stack abuse. What is stack abuse? Okay, first, let's say what is stack abuse. Design Python, using publish, Python privacy. Is this related with Stack Overflow? Apparently not. No, that would have been connected. Oh, my computer is struggling. Why is it struggling so much? Okay, let's say why it's struggling. Performance, CPU is eating almost full the memory. Okay, let's just say that. Okay, so Stack Abuse has nothing to do with the Stack Overflow. Maybe this one. I like this one. A double linked list is not such a difficult project. Yes, let's stay with this one. Scale stacks, implementing your own. Okay, now that you can know you can use collect decade for handling linked lists, you might be wondering what you practice in Python. So decade. So let's learn how a decade works. See? Real Python is quite quite awesome. I thought I had to do it myself. I'm just putting them. M L R U. Every time. Okay, so that's there. Yeah, just learn this fast. Linked list. There are no lists. There are not popular schools. You might not even know what linked lists are. When should you use them? Collection decade. Linked list needs. How to implement your own linked list. If you're looking to brush up on your coding skills, understand the linked list. Linked lists are an order collection of objects. So what does it make different from normal lists? Linked list different from lists in the way that they store elements in memory. While lists use a contiguous memory block to store references to their data, linked list stores a part of their own element. Main concept before going in depth I'm reading this fast because I'm practicing for the interview. Recommend that. Okay. Apparently it's good. Okay. For the list, different normal. Before going more in depth on what nickel lists are, you can use them. You should first learn how they are structured. Each element or nickel list called a node, and every node has two different fields. Data contains the value of the store in the node. Next, container reference to the node. So I have the data, I have the next. A collection of nodes, the first node is called a head, and is used for interactions through a list, pointing to none, to determine the name of the list. Similar purpose can be used to implement chaos or stacks. I mean, chaos or stacks. I don't care. Yeah, in stack you put this, you remove this, you put this. Okay, graphs can be used, relationships. So with a deck you can a dictionary. Cases a list. So I connect with two and none. The key dictionary. Source of practices. Okay. You could avoid storing known values, but we retain them for clarity and consistency. Okay, so this person think of this, clear even with this, store in memory, dynamic arrays. That means that memory size for both this and look at this is very similar. I need to read this. Since the difference in memory between this and look at this is something significant, it's better that you focus when it comes to time complexity. You can insert lists or append for a moment. You can use their control to remove and pop. The main difference between this method that insert and remove. Use append and pop at the end of the list. Now, something you need to know about Python. Remove names that are not at the end of the list. Require shifting in the background, making the operation sound complex. You can read the article mentioned about how lists are implemented in Python. Okay, I need to read that. With all this in mind, you want to insert certain elements. Open. At the end is of 1. You try inserting closer. Average is of n. Much straightforward when it comes to insertion and deletion. For deletion, when implementing keyword. Retrieval. When it comes to element lookup, lists perform much better than when you know which element you want to access. This can be performed. Yeah, you go first, second, you're going to get 1. Okay. Hasta la raíz. This perform much better than Calais when you try to. Then complexity. Let's try deck. The specific object in collections mode that you can use for linked list called deck bronze deck, which is stand for double-ended gateway, so that double linked list, which can access, insert, or remove elements from the beginning or the end of a list with custom how to use. There are quite methods that come by default with a deck object. However, in this article, you'll only touch on a few of them. Okay, so these are the docs, Python 2. So let's find the Python 3. Okay, there is user string chain map contract. Just say deck. Okay, this doesn't matter. Oh, this matters. First, you need to create the list. Like, go create an empty linked list if you want to populate deck with an array. Data object. You pass an iterable as an input, such as a string. These are objects. How to create a deck object. You can interact. Move elements you can create. So double link of this. Collections. Deck. So I happen at the end, like pop. However, you can also use that quickly to add or remove up and left or there. This happen. And stack. Okay, so the clear copy, create a shallow copy of the whole deck. Then index, insert, path, rotate. Okay, default deck. Okay, but how do I return something? reverse, rotate, pop, insert. To the right side, to the left side, up and left. I need that up and left. Remove an element from the right side. Remove, reverse, rotate. Pop. Up and doesn't return anything. And to pull. Okay, so decade. I need to go to sleep. So how long is that live stream? So like half an hour? Okay. Python put each. Second graph. Implement, top left. So what my experience tell me is that I need to take that decade and strip it out. I need to put when I have this cellular list. The hash set. Okay, I need to move this. A hash table. So let's say Stable Python. Stack Overflow. Okay, this. Yes. Okay. So what I need to do is the same. Just say it's empty. Okay. What I need to do is that let's say, how does it color? Does it color? So it says that this, let's say you call it put with with one. What needs to happen is the exists in one equals to another list to up and left, something like that. So when I need to remove one, I can just do this one, the something like that. Okay. So my experience tells me that I need to go here in this deck and strip it out and understand how it works. Variable max 9. What happens when I say up and left? Second is an object. I don't actually have the uh, Damn. Okay, so I say I'm going to be right back, but it's going to take some time and I need to go to it. So that problem goes for tomorrow. Bye. Thank you for listening. Thank you for being here. You, the one that is here. Maybe you sign an error. Okay, bye. See you tomorrow.